Which one? Function. How about Edward? Oh, you guys still in holiday. That's cool. You guys tried the homework from last week? Did you guys try the trig thing from last week? Hey, is this one or this one? Which one? Last week is this day. Yeah, here. Oh, last week we did a lot of coordinate geometry. Did we start the trig? Well, last week after we did a lot of coordinate geometry, what do we do? What
I
did
think
we
we
do?
just did coordinated geometry. I don't remember doing trig.
Okay. Because your school haven't started, we double check trig now. Your school term 2 are a lot of trig. Of course, we can mix function and trig together for today. Function and trig are, so we can focus on trig functions. It's a higher level. Trig functions. Some idea same as standard level. Okay, Oh, Kristen, so cool. 1 more week for holiday. Oh, let's double check. We double check trig function and the graphs. For example, everybody try to sketch this. Yeah, like these several graphs. We check function. Of course, you can say this function is fx. This will be 2fx. This will be f2x. That's trig. Trig. Oh, sketch graph. Normally we have domain. X just between 2 pi and 0, or 0 degree to 360 degree. The reading thing we learned last year. Well, we better, for higher level, we better use readings. Try to sketch the graph for sine. Okay? Try to sketch the graph. Next one, how you sketch this. Next one, how you sketch. Well, this is actually f inverse. This is called the inverse function of sine x. It's called arcsin x. In other systems, sometimes they wrote this. But in IB, we say arcsin x. Hello, long time no see. You moved to the central? Cool. What do you learn at school?
Functions.
Cool, we can do function. How you sketch it's like function. Like function. Okay. Sine graph. That's the basic one. Oh, I cannot ask you guys because just graph. Sine just here. This is 2 pi. This is pi. This is 1. This is -1. Graph. Try to sketch other 5. Okay, graph. You just start doing this. Which street you are now?
I'm very close.
Eden, how we sketch number 2? Ayo, that's a nice way. For the second one, if we sketch on the same thing, that will be here. That's the second one. Second one. Okay. This is in function. Eden, describe the transformation. What's the transformation from fx to 2fx? It's called the vertically stretch. Vertically stretch by scale factor 2. Did you guys learn this part? Vertically stretch. Well, you know the vertically stretch idea?
Yeah.
Okay, that's a function transformation. We try to use some trig to revise function transformation. And later we try to use trig to revise something called the composite function and the inverse function. Okay, so that's all function idea, but we use trig as examples. Normally, when you just learn function, there should be general thing, like quadratics, hyperbola, parabola, those stuff, and the exponential. Yeah, we try to use trig. Number 3, how you sketch it. If we make a different color for number 3, for example, we try to make a black one. Number 3, the graph on. Number 3, sine 2x. Eden, how we sketch it? Right, by scale factor half. This one, yeah. Number 3, we have this. That's number 3. Okay, fx to f2x. If 3 marks, Eden got 2 already. Horizontally stretch by scale factor half. It's got compressed. Function. Ellie, any question?
Nope.
Okay, that's the idea. Number 4, it's like 2 stretches combined together. Horizontal one and the vertical one. Kristen's still in holiday. AIC start school last week. Other schools start school this week. Kristen start school next week.
What is it? 3%?
Okay, number 4. If we sketch it, it's based a squeezed one, but this is 3 now. If you describe the transformation, you can say, horizontally stretched by scale factor half, vertically stretched by scale factor 3. That's it. So these several examples just show you stretch, show you the idea about stretch. Okay. Number 5. Arcsin x, how we sketch it. The sine inverse. First idea, we got a sine graph. Selvin, does this sine graph got inverse function? Very good. No inverse function. Why? Because after you inverse is no function. The reason it's not a one-to-one function. Not one-to-one function. Only for one-to-one function, there is inverse function. But you can always say there is inverse relation, okay? But not inverse function. The reason we just say it's not one-to-one function. What's the meaning of one-to-one function, Eileen? I got two, Eileen. What's the meaning of one-to-one function? Oh, Eileen not sure what's the meaning of one-to-one function. Isabella, what's the meaning of one-to-one function?
I'm not sure.
Eh? I thought you guys learned function in last year's standard level. Okay. I will show you what's one-to-one function.
There's one thing you tell every one line.
Yeah, we're asking what is one-to-one function. Like one x value, you only got one y value. One y value, only got one x value. Like the current marriage system thing. One x value, only one y value.
Really?
Okay. For example, I can show you what's not one-to-one function. This one is not one-to-one function.
No.
Parabola is not one-to-one.
好了，见了啊。
Who is talking? Parabola is not one-to-one. Not one-to-one. Why? We got 2x value share same y value. It's not one-to-one. Okay, so parabola, we can say this is many to one. Like several x values share a single y value. This is called many to one. The whole sine, of course, even more many to one, because we even know that for half, you got 30 degree, 150 degree, 390 degree, a lot. So this is a many to one function. Many to one. Isabella, you understand what's the meaning of many to one?
Mhm.
So one to one function, just like here. Oh, not this. Like this one is one to one. 1x, just 1y. 1 to 1. Okay? Oh, yeah. Okay. If you sketch this one, this is not a function. This is called one to many. One to many. Because one x value got so many y values. Any x value here, okay. Any x value here got y value, y value, y value. You got so many y values. One to many, not a function. Okay, so we got two types of function. Check one to one, many to one. One to many, many to many. These two function. These two, not a function. But they all call the relation. They all call the relations. For function, we use some idea called the vertical line test. To test if it's a function, we use vertical line test. What's the meaning of vertical line test? Check here. You just sketch a vertical line. How many intersections? If it's more than one, it's not a function. Vertical line, only one intersection. This is a function. Okay. So vertical line test. More than one intersection. That will be not a function. for vertical line test. If there are more than one intersection, it's not a function. Parabola still function because vertical line only give you one intersection here, just one intersection. Okay, Ethan, did you learn this? This is how we check if it's a function. Vertical line test failed, then it's not a function. What's the meaning of failed? More than one intersection. If it's already a function, we use horizontal line test. Like this one, horizontal line test, got so many intersections, it's not one-to-one function. If only one intersection, you got one-to-one. We better say if it's more than one. More than one intersection is many to one. Many to one function. Okay. Yeah. So if we sketch a flow chart, you have a relation and vertical line test. You try a vertical line test. Vertical line path test. Path and then function. Path means only one intersection. No. Not a function. Okay. And if it's a function already, we got the horizontal line test. Oh, path means at most one intersection. It's one-to-one function. Failed. Many-to-one function. That's how we check one relation if it's a function. Okay. Isabella, how about now? Isabella, how about now? It's what's the meaning of one-to-one function, many-to-one function? You remember now? Okay. Not function. Not function could be many-to-one or many-to-many. You don't need test. Yeah, just put 2 steps. Yeah, too many. If you do horizontal line test, yeah, pass just many to 1. Fail just many too many. You don't need test. Okay. Example, many too many, like a circle. A lot of y value got 2x value. A lot of x value got 2y value. Oh no, not function is 1 too many, not many to 1. 1 too many will be the one Tingmeng just designed on, like here. Okay. 1 too many, many to 1. Yeah, the part go first is about x value on x, y, x, y, x, y, x, y. Thank you, Val. 1x, there 1y. It's called 1y. Many x, same y. Many to 1. 1 too many. Okay, guys, check here on. I got some typo before. It's 1 too many. So that's the function on. So based on here, if you inverse this one, if you do inverse like yx swap, if you just change to here, that's not a function. That's why we say many to 1, no inverse function. Because after you swap x, y, inverse it, it changes 1 to many, not a function anymore. Okay, and then Katrina, any question?
No.
Okay, that's why sine x no inverse function. For this one, in general, sine x no function, no inverse But we can do something. We got sine x here a lot, never stop. If we just choose a small piece like this, just a small piece here, it's 1 to 1 now. Okay. This small piece, the domain is between 90 degree and negative 90 degree. Okay. For this one, we have inverse function. The inverse is arcsin x. But yeah, 2 Christian students got into London School of Economics. They just told me today. One called Judy, the other one called Jessica. Anyone know them? 2 years above you guys. Last year, Christian IB result really good. Last year. A lot more than 40. All the IB students try to aim more than 40 to be IB scholars. More than 40. Of course, including the EETOK, 3 marks. Okay. So, Eden. What's the name for this one? What's the name for this one? In your learning function, right? Inside the function topic, we can name these 2 parts. Possible x values is called yes, this is called the domain. This is called the range. This is called the domain. Tim, you learn domain range at school?
Yeah, but not at school.
Not yet, okay. Solve, okay? Domain the range?
Yep.
Okay, are you guys ready to try the very hard, not very hard one? Okay. I'll try to give you some examples. Check if you can do it. If you cannot do it, don't worry. We need to learn more to do it, guys. Arc sine x fx. We try to investigate some idea about arc sine x. This x is between 91 and 1. And y is between, we try to use degrees on negative 90. That's called arc sine x. This is the idea about the inverse sine. Without calculator, answer the following question. No calculator, Edward, what's arc sine half? It's the same as asking you sine how many degree give you half. Okay. Sine what give you half? Same as asking you sine how many degree? Yes, 30. Eden, what's arc sine 1? Or sine inverse 1? Sine how many degree give you 1? Yes, 90. Human, how about arc sine root 3 over 2? Very good. Bell, how about arc sine negative 1?
Is it negative 90?
Very good. Jenny, what's arc sine root 2 over 2? Hello, Jenny. Oh, in normal calculator, we just sine inverse root 2 over 2 on.
I don't know.
Or like a sine how many degree give you root 2 over 2? Do you know that?
No.
Okay. Ellie.
Is it 45?
Yes, 45. IP requires students memorize these values. Okay, it's like original one, you need to memorize this value. If you got theta, sine theta, 0, 30 degree, 45, 60, 90, right? 0, half, root 2 over 2, root 3 over 2, root 4 over 2, which is just 1, root 0 over 2, they all root, okay, 0, 1, 2, 3. Okay, root 0, 1, 2, 3, 4. That's about the sine. Okay, right? Remember that? Yeah. Okay, which means after you know some idea about arc, we need double check exact values. 请问 without calculator, how you show sine 30 degrees give you half? How you show that? Okay, I'll check other guys. Michael or Mikio, how you show sine 30 degree? How?
I think I will like draw a triangle with 30 degree.
What did he say? Yeah, we can do geometry. For example, if you sketch a triangle, Edward, what's the name for this triangle? Yeah, equilateral. 60, 60, 60. Okay. Eden, how we find the 30 degree? Very good. We cut in half. Okay. If you assume this is a Edward, what's here? 2a. Edward, what's here? 2a. Edward, what's here? 30 degrees. So Edward, what's sine 30? A over 2a, which is half. Similar way, try this one. Sine 60. We need the opposite. Check what's opposite. What's opposite? Really? The opposite is the height. 2a, a. How about here? And then square root. So root 3a. So root 3a over 2a. Root 3 over 2. Okay. That's how we prove sine 60 root 3 over 2. For new IB syllabus, there is a chapter called proof. A new chapter just called proof. Yeah, they will show you how to prove by deduction, how to prove by induction, how to prove by counter example, how to prove by contradiction, how to prove by negative how to prove that counter positive, a lot. Even some idea in logic. Counter positive. Do you know the meaning of counter positive? For example, I need to tell you what's the meaning of counter positive. If rain in tomorrow. Then we stay home. If tomorrow raining, we stay home. We don't go to a movie or something. We just stay home. I'll show you the definition here. Counter positive. Contour positive, sorry. Contour positive. Oh, if you read the English part is annoying, but the bottom part is easier. That's why we use math symbol. Contour positive of A, if A then B, contour positive. If not B, then not A. Which means contour positive, contour positive. Yeah, very good. Okay. Yeah. So A and then B, contour positive means if not B, then not A. What? Why there's a little head, a little cat come out. Okay. Contour positive. In logic, in mathematics, A to B and contour positive equivalent. If you can prove the contour positive correct, then A to B correct. Okay. For example, let's check a math one. X equals 3, and then 2x equals 6. Okay. That's correct, right? What's the contour positive? Oh, no. Contour positive will be 2x not 6, then x not 3. Okay.
But that doesn't mean that n has to be, because if it's like one, like it's just like many to one, you know?
Oh, we talk about logical. If you have some reasoning and how you make a not thing.
But doesn't also like quadratics.
Okay, for example, take one example. If x equals 3, x squared will be 9. The contour positive. This is not about trig function because we just mentioned some proof. I give you a small idea in that proof thing. If x squared not set 9, x cannot be 3. X, of course, x cannot be 3.
No, but x.
Not just cannot be 3, x cannot be -3 as well. Okay, just ask you guys touch some idea about contour positive. Because in some novel they wrote about like probably like about love thing. they do something not really true in logic. Okay, we're back to trig. Just gave you a small idea about the contrapositive. Contrapositive and the original one at the same time or wrong at the same time. Okay. Back to here. So we just proved sine 60, 30 values. Now it's time to double check a knowing question. Yeah, this is some extra thing, not in trig. Given sine 30 equals half, sine arcsin half equals 30. It just give you that question. What's the sine arcsin half? What's the sine arcsin 0.3? No calculator. What's the sine arcsin negative 0.4? What's the sine arcsin 2? Circle, Ethan, first one. Second one. Second one, 0.3. Next one. Next one. You mean sine something equals 2? Sine something always between negative 1 and 1. Okay. Always between negative 1 and 1. So you cannot have 2. Anyway, most case of course, you can just say sine arc sine x. The condition on x between negative 1 and 1, just x. Okay. Okay. The stuff I'm asking you is really just FF inverse, huh? The arcsin is called the inverse function. Katrina, any question?
No.
Oh, let's check something a bit harder. I swap the function now. How about this form? Edward, first one. Really? Check the table we just got. What's sine 30? It's half. What's arcsin half?
Sine 30.
Yeah.
20 degrees.
Very good. The first one just 30 degrees. Ellie, the second one.
45 degrees.
Very good. Jenny, next one. Oh yeah. 60, 45. Katrina, last one.
-45.
Good. Eh, do you feel this one hard? Timon, is this one hard? Because I haven't give you hard questions. Okay. Let's have a look now. Arc sine 150. Okay, I cannot. Arc sine 135. Arc sine 120. Arc sine. Ay, give you another one. 210. Arcsin 就 sine inverse 啊。Oh, I will try this 4 question. We try to mix inverse function and trig together. come on, first one. -30. What's sine 150? Yeah, we can use graph. Check here. Sine 150. Check here. We try to sketch a sine graph. And this piece is for arcsin. 180 degree here. 30 degree here. 150 degree here. Yeah, this is 30. This is 30. I do one next one. Good. It's the same as here. Same as here. The next one. No. Check on. 180. 120. How about this side? Yes. 60. For sine inverse, we just need this piece. -90 to 90. Which means when you arc sine, the answer always between 90 and the -90. Arc sine answer are always between. Katrina, the last one was the answer.
-30.
Oh, excellent. Because 120 is right here. Same as -30. The value is same as -30. Okay. How about another one? Arcsin. Sine 330. Isabella,
-150.
you. Let's have a look. The answer must be between -90 and the 90. So -150 not right. Guess another one. This is 360. 330 is right here. So you can check. Oh, 330, since 330 value is here. We need this value and the inverse. -30. -30. Or you can check this one equals -½ So sine inverse -½ just -30. This is hard one. This part is hard. Okay. This is some function. For trig function, we need to revise another part. Something probably learned this part before. Right here. Still sine. Still sine. Because we do a lot of sine. Cos should be similar later. So far check what we did. We did sine graph, stretch. Okay, horizontally, vertically. Sine inverse function. Some idea. This is general idea about function. This is general idea about function. And here, some exact values. It's called the special angles. Exact value. Random thing, contrapositive. Here, if sine x and arcsin x mixed, for example, if you say fx equals sine x, gx equals arc sine x. This one, this part will be fg. This part is GOF. It's called the composite function. Either you learn composite function. Okay, composite function. How to spell composite, Eden? Is this the correct spelling? Okay, composite function. Okay. Now, still sine on. Some time. This one, coordinate 2, 20. This one, 8, 6. Oh, this is some graph. right here. Okay, this is time, this is height. If it's given h equals a sine bt minus c plus d, what's a d b c? Oh, double check 啊。Okay. Human was A. Very good. AR. E, nice. Okay. Maximum divided by 2. Of course, y value 7. D, just the value in the middle. B. 听吗 Pardon? Oh yeah, if you use degrees, if you use degrees, we use 360 divided by period. The period is 12.听吗 The period is 12. So it's 30, not 15. Or if in readings, 2 pi over period. Very good, Jason. How we calculate the C? This is C. This is C on. Oh, this is C. Just this is C. Next one. Which one plus 8? Oh, you can do this one minus 12 because the period is 12. This is 14, right? Two, 8, 14. This is 11. And here is 5. Double check if you understand this. Okay. You really understand how we got C? Like the whole period, you can have a look on. The whole period is 12. So up to here is 6. 6. Or you can check here. This is these two. Between these two give you 6. So here 3, here 3. If here 3, we got -1 here. That means cos graph is translated to the left by 1. That's why we say t plus 1 translated to the left by 1. We plus 1 here. plus 13. That's the equation. Okay. Plus 1 move to the left by 1. Okay, Ooh, okay, good question. Let's check 听们这个 question. Describe the transformations from ft to gt. Okay, describe the transformations from ft to gt. We got the stretch, we got translation for this question. These are the transformation. We have both what we call the horizontal translation and the stretch. Okay. Translation. I'll give you different answers. First one. 1. Horizontal stretch. Stretch by scale factor. 听懂? Yeah, 6 over pi. Vertically stretch by scale factor 7. Translation by vector -1, 13. Okay. Oh, someone did different way on. Let's have a look. Oh, for Jason, if sine in 2x, the scale factor is 1 over 2 because it's got compressed from here to here. It's narrower. Sine 2x. Okay. Let's do another way. Okay. If it's a if I did translation first by horizontal stretch by scale factor 6 over pi, vertically stretch by scale factor 7. Question, what here?
Wait, so
Yeah.
was this sine x? Like sine x?
Sine x.
Like horizontal stretch, right? So was this sine 60
Oh, still the same question. Still from here to here. Horizontal stretch still pi 6 over pi. Vertical stretch still 7. We're doing the same question. Just I try to ask higher level people, if I put the stretch at the end, do you need to change the translation? That's the question. Can you still use 9113? Can you still use that? Well, can we still use 91 and 13?
Maybe. No.
Maybe no. No is correct. For example, if you really just use -1 and 13, what happened? The first step, sine t got changed to sine t plus 1 plus 13, right? And next step, change to sine pi over 6t plus 1. Next step, 7 times sine 6 pi over 6t plus 1 plus 13 in the bracket, which means, is that same as the previous one? Same? Which one plus pi over 6? Oh, if it's a horizontal stretch, fx just change to f2x, only x times by 2. In this case, only t times by t. What happened now? It's different. Because if you expand this one, you got 7 sine pi over 6t plus 1 plus 91. Our original one is 7 sine pi over 6t plus pi over 6 plus 13. Check out. If you change the order, check what happened. What happened? No, this is not right. Guys, it's time to ask you number in the question mark. You times by 7, so 13 over 7 pi over 6. This page very important. This page very important. Okay, oh, negative. This is negative pi over 6. Negative pi over 6. Plus, so you move to the left. Yeah, I'll try to share some revision questions. I think Tim also got some mock coming, right? Because year 13 got term 2 mock.
No, because they tend to want 3 or 4.
Okay.
Because we have
You haven't really learned that much higher level.
So there's a limit.
Yeah. Term 1, you guys really learned something not IB. Okay.
Not with.
Yeah, you got prepared.
Oh gosh.
Yeah. Okay. See you guys. I'll share some homework.